today, our objective is really still the same, of learning how to use the mole as in a conversion process. We're now just going to bring in a different unit than grams. So last time, and what we just reviewed, are converting moles to grams, grams to moles. Today, we're going to talk about the relationship between liters and a mole. Okay? First off, turn to your table buddy and tell them, what is a liter a measurement of? Ready, go. Turn to your table buddy, tell them what that is. What is a liter of a measurement of?
It randomly came there.
Thank you. Okay, so first off, just understanding the word, what is the difference between, in a sense, using a liter as a measurement versus a gram as a measurement? Anyone willing to share that for us? Go ahead, Kate. Yeah, so Kate said one way to look at it is liters is often what we use to measure a liquid substance, right? Versus like when something's a solid, you would most likely measure it in a gram. And that is very true. Kate, have a smiley face for that. That yes, you can measure liquids as a mass, but it often tends that we weigh them as, or we measure them as a liter or a volume measurement. There's actually another thing that's not as common because it's not something you do, I would say, as often, but we only measure them as, or we more likely measure them as a volume versus a solid, or grams are gases. So gases also fall in this category that I'm more likely to measure them as a volume than I am to actually measure them as a mass. A lot of times because it can weigh very, very little, right? Particularly if you think of a balloon, right? A balloon is filled with gas, but it's going to have very little mass. But if I measure the volume of it, that can also tell me about it. So in our case, if you want to emphasize here at the top of your notes, in our case, we're actually going to be focused only on liters of gases with this relationship. The relationship we're going to learn today does not work with liquids. There's actually a whole different one we won't even cover in this class. But there is a way, once you understand this process, to still do it. Okay? So the idea of this relationship, where'd you go, mouse? Okay, is when you are at what is called STP, which is known as standard temperature and pressure, which is 0 degrees Celsius or 32 degrees Fahrenheit and 1 atm of pressure. Okay, we have found that 1 mole of any gas will always occupy 22.4 liters of volume. Okay, so there's this cool relationship that it doesn't matter what type of gas you have. If you were at standard temperature and pressure, the balloons would all be the same size, 22.4 liters. Okay? Now, if you're not at standard temperature and pressure, this relationship doesn't hold true anymore and you can't actually use it. So all of our problems are going to be at STP, because otherwise it just gets way more complicated how to make it work. The idea is because if you change temperature and pressure of the outside situations, it can change the volume of something. Oliver. Where's my paper? Are you looking at the thing above? Oh, that was from last time. So that's the molar mass. So yeah, last time's relation, oh no, wait, just kidding. We're looking on this one. For this one, so you're gonna use the 22.4 liters, so that's what we're gonna use. So that's kind of the nice thing about today is last time, the number you used was always changing because it depended on the actual mass of the substance. Today, the number's always the same. It's always 22.4 liters. The matter is you just have to make sure you set it up correctly of whether am I dividing or timesing by it. Hi, Kayla. What's up? everybody is the QR code to get the song in the hallway to stop. So you
So you guys
scan
are the
this,
luckiest that you got with Sundays.
donate money, thanks Caleb, and then the song will stop, but more importantly, you're gonna help people, right? Like that's what you should do it. But if the song goes too. So I'll put this, where should I put it? You wanna pass it around?
On the door.
On the door, so as you like leave today, you'll scan it. I'll just hold it as you leave. Would that work? Well, I messed that up. I'll put it here for now, and then I'll put it on the door. So. Okay, so let's take a look here once again, just to visualize what this is saying. So imagine everybody if I had a balloon of neon gas, a balloon of oxygen gas, and a balloon of carbon dioxide gas. Okay, if we are at standard temperature and pressure, 1 mole of all of them will always be 22.4 liters. Now, what do you notice though is different about the 3 balloons? The mass. Okay, they're going to have different masses because 1 mole of neon, as we did last time, isn't the same mass as 1 mole. But in terms of the liter relationship, it's actually the same, which is pretty cool. Okay, questions on that before we try some problems? Okay, let's go ahead and try some problems out here. Okay? All right, we're going to do number 1. I can't write that high, so I'm going to do my work right here, but make sure you write it underneath number 1, okay? Yeah. Okay, so just like last time, you got to start with what you know. So it tells me I have 19.1 liters of chlorine. Okay, so start with what you know. So this is number 1. Once again, I'm just writing it here because I can't write it there. Okay, so we have 19.1 liters of chlorine. Our goal is to convert this into moles of chlorine. So just like before, set up your conversion. The unit I'm trying to change always goes on the bottom. So since this is liters, the bottom should be liters. What am I trying to change it into? A mole. So mole goes on top. Once again, I'm changing my colors to emphasize the unit changing. And once again, that these units should always match. Now, what goes in here is what makes these two things equal to each other. Once again, all your conversion fractions are independent of the actual problem. They're just a true statement. So if I'm comparing liters to moles, what was the relationship we just learned? 1 mole equals 22.4 liters. Once again, you should always be able to read this and it makes sense. If it doesn't, then you probably put your numbers in the wrong places, like saying 12 feet equals 1 inch, right? It doesn't make sense. And then calculator-wise, because this is on the bottom, you would do 19.1 divided by 22.4. Questions on my setup there? Caleb, what'd you get with that? You plugged that in. 25?
0.8.
Oh, that's so good. 0.85 moles of Cl. Questions on that? Okay. Does it feel similar to what we did last time? Right? Like it should hopefully feel like this is the same thing, just a different number. Okay? All right, here's what I'm going to have you do. I'm going to have you do questions 2 and 3 on your notes. You can do them with your table buddy or by yourself. Once you think you've got them, raise your hand. Once I clear you, then you can get started on today's homework, which is the backside of last time's homework. Now, it's only 5 problems, and being that it's even faster than last time, it shouldn't take too long. And so the rest of the time is to work on that mole project because that is due this coming Friday. And we won't have as much time on Thursday during class as we do today. Okay, so finish the homework and then work on the mole project, but unless those 2 things are done, you shouldn't be on your phone or doing anything else. Okay? me know if you have any questions or when you're ready to pass off and I'll come check it.
On your script.